Hello. I wanted to do a quick video about slope-intercept form and point slope form because I didn't find a lot of videos available that give you an actual real life situation. It's usually just here's a point and here's a slope, write an equation. So I was at the donut shop this morning and was looking at their pricing structure and thought there is a good example. So we're going to take these prices and I'm going to go to Desmos and put them into a table, and we can graph the points and see what we think the equation will be that represents the price based on the number of donuts. So going into Desmos, I can add a table here. And I remember the prices, well, it was 4 donuts, 6 donuts, 8 donuts, and 12 donuts. And the prices were $4.95, then $6.95, then it was $7.95, and then $9.95. Okay, so you can see those are graphing the points there. So I'll move this so we can see them all. Okay, maybe zoom in one time. It's a little too far. I'll zoom back out again. Okay, well, you can see they're not all on the same straight line. But I believe the last 3 are on a straight line. So I'm going to temporarily ignore the first one, the 4 donut price, and just focus on the other 3. So what I can do is take 2 of those points, 2 of those ordered pairs. It doesn't matter which 2. So I'll grab the 6 and $6.95 and the, let's say 12 and $9.95. And then if I figure out the slope there, or the rate of change, there's an increase in the X of 6 donuts. Okay. And there's a price increase of $3. So if I then make a fraction with the rate of change, the change in Y over the change in X, that will be 3/6. Type that there. Okay. And if we reduce that, then we get 1/2, which is telling us that based on those prices, the price is going up $0.50 for every donut. So the rate of change here is 50 cents per donut. So we could have that as a fraction or a decimal. Doesn't really matter. So an equation that we can write here in point slope form, which is, there are a couple different forms of this depending on what textbook you're using or what video you're watching. The Y0 might be over on the other side with a minus. But if we start with this form, then our equation can be Y equals 1/2 times parentheses X minus, then you pick one of those 2 points. So I'll pick 6. And then the Y0 value would then be $6.95. That would be an equation of the line in point slope form. We could have used the other point. Oops. Come on. And had X minus 12 in the parentheses, and then we would have plus $9.95 on the back end there. So either one of those would be acceptable. Those would both be equally good answers for the point slope form of that equation. And so I'm going to type one of those into Desmos now and graph it and see whether we really do get the line that we thought we got. I'll just move this out of the way. Okay, so now if I type this into Desmos, Y equals 1/2, make sure I get out of the denominator there. X minus 6, close parentheses, plus $6.95. Boom! It does look like it's going through those 3 points. Well, what would the first price have to be for the 4 donuts to lie on the same straight line as these other ones? If I click here on the line, I'm so close. There. Oh, I had it for a second. Come on. $5.95 would be the price that would put this one in line with all the others. So I'll go temporarily change that price. There. So now, if the price of 4 donuts is $5.95, they are all on the same straight line. And we can get that line in slope-intercept form in a couple of ways here. We could either take our point-slope form and do some algebra and distribute the 1/2 to each term that is in parentheses, and then combine like terms with the 695. So if we did that with, I'll just delete this. If we did that with the equation that has the 6 and the 695 in it, then just showing some steps here, we'd have y equals 1/2 x minus 3 plus 695. So that would be y equals 1/2 x plus 395. So what that tells me is we already knew that the slope was the price per donut. So it's a $0.50 per donut. Maybe I want to go decimal with that instead of fraction, just so it looks like money. And there, I think that looks better. So the slope there, the value of m is the rate of change. So that is 50 cents per donut. But there's this extra flat fee of $3.95 added on to each order. So you could think of that as the price of the labor of having someone make the donuts and package them up for you and smile at you at the register and all that. So we can also see that from the graph by clicking on the y-intercept there. And we can see that according to this formula, if you bought 0 donuts, they would charge you $3.95. Of course, that's silly. But for any one of these other values, of course, I changed the value of the price of 4 donuts to make it fit my example better. That would be $5.95. And again, that would be, whoops, come on, we can do this. If it's 50 cents per donut, 50 cents times 4 is $2, plus the extra $3.95 brings that up to $5.95. And that works for any of these other pairs. 6 donuts at 50 cents each would be $3, but this is, then you add $3.95, you get $6.95. This point we haven't talked about. 8 donuts cost $7.95. Come on. 8 donuts times 50 cents is $4 for the donuts, plus the extra $3.95 added on. So there you go. They all fit this pattern of, if you take the number of donuts and multiply it by 1/2 or by 0.5, then you add on an extra $3.95, you will get the total price of those donuts. Yeah, so I'll just go back to my point slope form here. I could change this to 12 and 9.95, and you'll see it's the same straight line. And assuming that the 8 is exactly on the line here, which it is, we could change the input for the number of donuts to 8, and then the price to $7.95. And again, we get that same straight line. And golly, I guess I'll just graph it as y equals mx plus b. And then I think we'll be done. Y equals 0.50x plus 3.95. It's the exact same line. I don't know what these points are here. Something weird's going on there. But we do get the same straight line. Now it's in red instead of in black. Okay, cool. Well, there you go. So I wanted to give you an example of a real life situation where you might have a linear situation, again, assuming that this is $5.95, and showing you that you can, there we go. We can take a pair of individual points, and the easiest way to get started writing an equation then is with the point slope form. And then if we want to transform that into slope intercept form, we can do that just by distributing and combining like terms. All right, well, thanks for watching, and I hope you got something out of it. I'll see you on the flip side. Flipping donuts.